All right, so let's get started. Thank you all for joining. So in the next around 40 minutes, we will dive a little bit how we can use structured task scopes and ScopedValues to get more out of virtual threads for our applications. So short introduction to myself. My name is Christian. I've been working as a software engineer for the last 15 years now. Started back with Java 5, and then like 8 years ago when Angular 2 was released, I switched over to more of a full stack role, and since then I'm now working in the front end with Angular, JavaScript and TypeScript, in the back end still with Java and the whole Spring ecosystem. I'm also a Microsoft MVP for web and developer tools, do some trainings on this for Java stuff, and I'm also doing really enjoy speaking at conferences, also listening to other people talking about stuff they really enjoy doing. And I'm also a content creator on YouTube, so if you're interested in really advanced TypeScript stuff, you can go to TypeRocks. There you can find really advanced stuff like you can do with the type system in TypeScript. If you want to get in touch with me, you can visit my website, type.rocks. There you find my LinkedIn, GitHub, and also my YouTube channel. And I will upload, of course, the slides and the code I will show you today also on my GitHub. So if you have questions, you can ask them all the time. You can just go to type.rocks/QA. There you can enter your question, and at the end of the talk, we will then answer them. Of course, you can also ask the question at the end, but if you're just thinking about a question during the talk, just enter it and we will go through them right away. So what will be the topics we will talk about? The first thing, I will give you a brief introduction about virtual threads, like how they work, but I will not go like into the detail how they work. Then we'll see how we can use the structured task scope, the new preview feature now in its 5th preview in Java 25, and then also why we should maybe use ScopedValues when we decide to use structured task scopes together with virtual threads. So let's get started with virtual threads. Now, as mentioned, I will not give you like an in-depth explanation about this. If you're interested, you can go to type.rocks/VT. This will redirect you to a YouTube video of a DevOps UK talk I did, where I show you in detail how they work. Like we will also look into the JVM code and so on. But in this talk, I will keep this quite short. But let me show you how we can use virtual threads. They are available since Java 21 in their final release, so there's no more preview. You can just use it. Maybe quick show of hands, how many of you are using Java 21 or newer in production? Nice, half maybe, so maybe you already are using it, or maybe you could use it. So let me switch over to IntelliJ here. So the first thing we will do is, we will have here a small Spring Boot application. This is just an empty one. I'm using Java 25 and Spring Boot 3.5, but everything I show you now in this section, you can also, of course, do with Java 21. We will create like a fake web application, which you can use to just query an endpoint and get information about the talk of a conference. So I will create here a main controller, and let's say we have our REST controller in here, and we have a request mapping, and everything is behind an API. Now we will create a get mapping here, and we say /talk/speaker, and now we return a talk when this gets called, and we have our path variable here for our speaker, and then we have our string here. Now what will this return? This will return, of course, a talk, and in our case, this is quite something simple. This is just a record which just contains one property, the name of the talk. Now, of course, what we now could do is we could use like a blocking REST client, a real REST client, and could do some HTTP calls. But I don't want to do this, first because I don't want to rely on the Wi-Fi, but also I want to have like a reproducible example. So this is why I will create my own REST client, and this is just a really simple class here. I say I have this fake REST client, and this will just be a new service here. And now when I get a new request at get call, I will just return fake REST client, retrieve talk, and I pass my speaker. Now what will happen when I call retrieve talk? It will happen the same as when you would use like a normal REST client. The thread you're currently using will get blocked, because when we have this blocking model, we have, for example, 200 threads in our thread pool, and one request blocks a thread until the response comes back. So we will say here return new talk, and we say talk for speaker here, and we have our speaker. Now, of course, this would be instant in this case, but of course, this is not the case in real life. So we will create a new getSleep function here, where we have some milliseconds, and I have a thread sleep of these milliseconds. I just create this function so I don't have to use this try catch all the time. Now in here I will use get sleep of 1000, and what this will do, of course, is it will just block the thread like it would also be blocked when we would do a REST client call to an HTTP endpoint. So what we now can do is we are already done with the first example. We can now start it. And what I now will do is I will just open JMeter. JMeter is a simple application to do performance testing for your application. You can do this for any kind. I will do this here for the HTTP request for API/talk. And I will do a performance test with 1000 concurrent users. And I will do this for 20 seconds, but I only will start to check how much time it takes for a response after the first 10 seconds, so when all the threads are already working. So let me start this. Now what happens is we have this thread pool of 200 threads by default in Tomcat. This means the 200 first threads are fast, but then we enter this thread block, this thread sleep, which blocks the thread. And this means all the next threads with all the next requests have to wait until a thread is available. So this is also the case. So what this will cause is, when we check the graph, we can see here that this will start at 1.6 seconds. For the one in the back, it starts at like 1.5, 1.6 seconds, and it goes up to over 4 seconds for a response. Because we have this delay of 1 second, and of course you could also have this delay when you do a real REST call, when you do a slow database call, when you are reading a file. Anything which blocks the thread will cause your threads to be occupied, to be exhausted. Now let's fix that. Let's go in our application properties file, and you can do this since Spring Boot 3.2. We can use Spring Threads virtual enabled and set this to true. Now I did not change anything else in the code. I just restart the application, and now let's do the test again. Let's clear everything and let's run this. Now what this will do is it will no longer have this thread pool of 200 threads, but for each request which enters our system, a new virtual thread will get created. And we will see in a second what the difference is between a virtual thread and a normal thread, but we will see also in a second how much faster this will be. Because basically now we are no longer limited by these 200 threads. We can create millions of threads, and they are extremely cheap. So you can see here we are already done. Let me show you the graph, and we can see here this takes exactly 1 second for each request. Now, you're maybe thinking, well, how does this work? This sounds a little bit like magic, right? So what is the difference between a virtual thread and a normal thread? A normal thread is the thing we know since like Java 1 or Java 1.2, where when you create a new thread, at the same time, a thread on the operating system gets created. Because a thread is nothing else than a connection to the operating system which you can use to do stuff on the CPU. And because creating such a thread on the operating system is expensive, first it takes time, second it also takes memory, you can't just create as many threads as you want. Because one thread is around 1 to 2 megabytes of memory, you can configure that. So this means if you create 200 threads, this would like take 400 megabytes of RAM. Like if you would create like 1 million threads, this would take like 1 terabyte of memory on your system, and this would just not be working for a normal application. And this is exactly the difference between normal threads. So when you hear stuff like platform threads or worker, these are always the threads which also have the equivalent on the operating system. And virtual threads are a construct only living in the JVM. So what happens is when you create a new virtual thread, this only lives in Java, in the JVM, and does not have a corresponding thread on the operating system. This makes it extremely cheap. So this means like you can create easily 1, 2, 3, 4 million virtual threads, and it will not cost you that much memory and also will be really fast. But how does this work? Because we have learned that we need an operating system thread to be able to do stuff on to use the CPU, right? And the virtual thread does not have this equivalent on the operating system. Well, this works like that. Let's say we have this talk endpoint we have seen. Well, a request comes in, then we create a new virtual thread because we are no longer using this thread pool, create a new virtual thread, and the virtual thread is looking for a worker thread, for an available thread in a pool. And these worker threads, they have a corresponding thread on the operating system. So they are looking for any thread which is available, connect themselves onto this normal thread, and will do its work. But the clever thing is that as soon as the virtual thread understands that it is blocked, it will remove itself from the worker, move itself onto the heap. So this means that this worker thread is now available to do other stuff, to do stuff for other virtual threads. And as mentioned, I will not go into detail about like performance and all that, but in my other talk, we can see, for example, you can easily have a million threads and only 40 worker threads. This is because most of the time a thread is just idling. It's waiting for input, output, for database, for HTTP call, for reading a file. A thread is not really doing much in Java, basically, if you don't have a computation-heavy application. And the cool thing is also, as soon as the virtual thread gets the signal from the operating system, oh, okay, I'm ready, I can now continue my work. In our case, when thread sleep is over, it will look for any available worker and connect itself to it. Now, you maybe have already spotted it. This is not the same worker thread, because it doesn't matter which worker thread it uses, because it's just a tool for the virtual thread to do the stuff. So this means for you as a developer, you don't have to care what kind of worker thread is beneath it. For you, you don't have to care if it's a virtual thread or a normal thread in like 99.9% of the cases. So let me now show you why it's not enough to only use these virtual threads. So why should we also use some additional features from Java 25? Now let's go into IntelliJ and let's switch into our main controller. Let's now say we want to get some additional information from our speaker. Let's say we have our get mapping here and we say /speaker and we get our speaker here. Now we will return a speaker and we say get speaker. We do the same here with our path variable. We have our speaker and we have the speaker here. Now what we want to do is, in this speaker, we want to return two properties. The first one, of course, is we want to return the talk. And the second one is we'll return some information about the speaker. Now, what is this information? This is just a simple wrapper around a list of strings in our case. So we have our info list here. And what we now will do is, first, of course, we get the talk for the speaker. So we call retrieve talk of the speaker. And now we want to query different endpoints and we'll then use the information endpoint with the most information. So we have, for example, info Google, and we have our fake REST client, retrieve Google, and we have our speaker here. And what this retrieve Google will do is it will return an info object, and we say return new info, list of speaker, and for example, also my birth date. Now, of course, this also in reality would take some time because it's an HTTP request. So I add a 500 millisecond delay. Let's copy this 2 times. And now we will do the same also for LinkedIn, where we also say, for example, I add some more information. And we will do it a 3rd time for Facebook. But this will be different because I'm not on Facebook. So I will say throw new runtime exception, no data found. So what is now the issue when we use this 2 more times? First, of course, let's rename this here to Facebook and also rename this here to LinkedIn. Now let's get the result with the most info. So we have our most infos here, and we will use a stream of our results. So infos Google, infos Facebook, and infos LinkedIn. And then we are using a comparator. So we are just getting the element with the most results in the list. So we are having our info here, and we say info.infolist.size. So we are getting the one with the most information. Now, the next thing we are doing is just returning the speaker with the talk and the most infos. Now, the issue with this approach is, of course, that we are no longer having this issue that we don't have enough threads, right? We don't have just these 200 threads, but instead what we have basically limitless threads when we enter our request. But the issue we now have is still that this code is blocking. This means that in here, everything is done after another. So this here will take 1 second, and this will take 3 times 500 milliseconds. So this means that when we return this new speaker, this whole request would take 2.5 seconds. And we have a second issue. The second issue is with this exception, which happens here for Facebook, because this would end our whole request. This would just throw an exception and our whole request would fail. So you would need to handle this ourselves. Now, you're maybe thinking, well, we could now use reactive in there, right? We could have our endless virtual threads, and in there we are using reactive. Well, first, when we are using reactive programming, we don't really need to use virtual threads, because reactive programming is exactly doing all the work for us, so that we don't have these thread pools which just are not enough. They are basically asynchronous. They are doing the stuff non-blocking. But the issue is, when you're doing this, then your code would look like this. You would have to rewrite your complete endpoint until your database to make this asynchronous, because you would have to use like completable futures. You would have to also use web client instead of REST client with Spring Boot. You would have to use, when you're using a database, you would have to use an R2DBC driver instead of a JDBC. So you would have to rewrite everything, also all your calls or your functions, everything has to be asynchronous. And this is not even everything which you would need to change. Here we have this error wrapped, and this error wrapped here is not even in the slide. So, and also it's so much boilerplate code, because you can see that only thing which is really important are these two lines here, where we are just getting the result of our information. Everything else is just error handling and aggregating. And this is exactly why we should use structured task scopes instead. So let me show you how we can do this. But this is basically what I did with this part we are now doing before when Java 25 was released. Because from Java 21 to Java 24, the preview feature did not change at all. But with Java 25, they completely changed how this structured task scope works. They basically threw everything away regarding the API and rewrote everything. So I had to completely redo this whole task, this part. So if you are not using Java 25, this code will not work for you. If you're interested how this works earlier, you can just go to YouTube, type in structured task scope and my name, and you find like a talk from 1 year ago, and there you see how exactly the same works, but with an older Java version. But of course, I would not suggest that you do this in production, because if you switch to Java 25, you also have to rewrite this. So I would still be a little cautious. But let me show you how this works. So let's go back into IntelliJ here. And the first thing we will do is we will move this out in its own function. So let's just remove these comments here. And then we will just take this code and move it in its own function so that we can work with this. So what we first will do is we will create a new structured task scope. Now, when you hear structured task scope, this is nothing else than just a fancy executor service. You can use a function to send new requests to this structured task scope, and this will then just create a new virtual thread and will run your task in this virtual thread. So let me show you how this works. We just create a try with resources block, and we say we have a structured task scope.open. And in this structured task scope.open, we now wrap our whole function. And what we now can do is we can use the scope fork function. Now we can see this takes a runnable, so we can pass it like a lambda, and we get back a subtask. Now a subtask is similar like a future or completable future, and it can have 3 different states. The first one is success. This means the result which comes back was successful. There were no exceptions. The second one is failed. This means there was an exception in your code which was thrown. And the third one means unavailable, so it's still ongoing. So what we will do in this case is we will just wrap our normal blocking calls with scope.fork, and we will wrap it like this. And now we will just pass our blocking calls to this function here as an argument, and we will get back a subtask. Now what the Java will do under the hood is it will create 3 new virtual threads, and now we need to tell Java where do we want to wait until all of them are done. So we do this here right after our last info call. We call scope.join, and this tells Java that we want to wait until all of these are done. So if we are reaching this line, then we can be sure all of these subtasks have ended, either successfully or failed. Now, what we of course need to do is we no longer have the real result here in our stream. So we need to filter it first, and we have the task in here, and we say task.state equals state.success. And because we are only interested in the successful ones, because in the ones which failed, of course, we cannot use. So we then use map here, and we say subtask.get, because we want to get the value out of our successful subtasks. Now, this is one thing which changed between Java 24 and Java 25. This code would have worked perfectly fine prior to Java 25. But now this code will throw an error, because let's check what open does, because this will throw a failed exception if any subtask fails. Prior, the default behavior was it just ran through all tasks, and then you could just handle the results yourself. It would not fail if one of the tasks was not successful. Now they changed that, so what we now need to do is we need to configure the behavior here. And we can use a so-called joiner to do that. A joiner is just an interface which can get implemented, which changes how we handle the completed and the results of our structured task scopes. So we can use joiner here, and we can see here we have some default implementations like await all successful or throw, any successful result or throw, and so on. Now in our case, we will use await all, because this will, again, as before in Java 24, wait for all of the responses to come back, and only then we can handle the results ourselves. Now, this would work perfectly fine. So if I add the exception throwing here, this would now take, again, of course, 1 second. This would take 500 milliseconds. And this here, of course, would then take 1.5 seconds to return everything. Now, this would work perfectly fine, and you can do it like this. But, of course, we can make this a little bit more concise, because we can create our own joiner and make use of some new features of Java 25. Because what we now can do is, with the new implementation, with the new preview, we can use the return value of join. We can override what join returns. In await all, join just returns void. It doesn't return anything, but we can change that. So let me show you how we can create our own joiner and encapsulate the logic in there. So we'll just create a new class here, and we call this class InfoJoiner. And what we do in here is we say implement joiner. And what this joiner takes is, it takes 2 generic arguments. The first one specifies what kind of results we are expecting from our scope fork call. So in our case, this is info. So when we go back into the main controller, this is what we are what kind of lambda we are expecting here. So in our case, we only want to allow the scope fork to be called with a function which returns an info object. So the second argument is what kind of result we are expecting when we call scope join. So with this, await all, for await all, this would be void. But in our case, of course, because we want to return just the best information or the one with the most information, this is also info, because we are returning a single info object. And now what we do, of course, is we implement some methods. We can see here we have 3 methods we can implement. The first one is result. This one gets called when we call scope join, and this will then get called, and so we get the result. The second one is on fork. This one gets called when we call scope fork and before a virtual thread gets created. In our case, this is not really interesting. And the last is on complete. And this is also interesting for us because this gets called as soon as a subtask finishes, either successfully or failed. So we implement result and on complete here. And what we now do is we can update this joiner so that we can really easily gather all the results and then get the one we want. The first thing we will do is we'll create a private final collection, and we say this is of type info, and we have our results in here. Now I'm using a concurrent linked queue. Why not an array list? Because we have multiple threads which access this array list, and array lists are not thread safe, so we have to use a thread safe collection. The next thing we do is we will create a collection for throwables where we store our exceptions. And now we can really easily check each time on complete gets called what we want to do with our subtask. The first thing is we say, well, if subtask state equals state success. In this case, we just use results.add and use subtask.get to get the result of our successful subtask and add it to the results. Now, otherwise, if the subtask.state equals failed, in this case, we just add it to our exception, But here we are not using subtask.get because the call was not successful. Instead, we are using subtask.exception to add the throwable, so the stack trace, to our exceptions list. Now, you have maybe spotted here we have this Boolean which we need to return. What is this Boolean for? We can say to our scope if we want to close or cancel our scope if this specific subtask is done. So when I would say return true, then as soon as this subtask would be done, then the scope would be cancelled, would be closed. This is, for example, useful when we say we want just the first one. Then we can say as soon as we get one successful one, we just return true and close the scope because we're not interested in the other results. In our case, of course, this is not the case because we want to just end the scope when we call scope.join. So we handle this ourselves. Now, in the result here, this is quite easy. We say we have a new runtime exception here, and we say all failed. And we say, well, if the result is empty, we will create this exception. And we can do a cool thing. We can say for each of the exceptions we have, we add them as a suppressed exception to our runtime exception, so that when we return our runtime exception in our stack trace, we then still have all the exceptions which happened in our subtasks. And in this case, then we just throw our runtime exception. Now, of course, in our case, this will not be the case because we know we have at least 2 results. So what we'll do is we will have our results, we stream over them, and now we can go back into the main controller, and in here we can use this max or else throw and use it in our info joiner. Because here we don't have to do a filtering, here we don't have to do anything because we are here only working with the results. Now, when you're also looking at this code, right, this code is quite small and easy to understand, and you can easily test this. You can just create in your JUnit test a new info joiner, then you can call on complete 2 or 3 times with different subtask results, and then you call just result, and you get your result. You don't have to use like a framework to put asynchronous code into synchronous again for your unit tests. This is all still synchronous code. Now let's use this info joiner in our main controller. So we can now throw away some stuff. The first thing, of course, is we use here the info joiner instead of the joiner await all. Now the next thing which we no longer need is these 3 assignments, because we don't have to stream over the results. We are doing everything in the info joiner. Also, we no longer need this return because everything is also, as mentioned, done in the joiner. And now we just return the result of our scope join. And this is exactly what we did in the info joiner with this second argument when we go in there, because we tell our info joiner that this will be the result we are expecting, and when we call scope join, this result function will get called. So when we now go back into the main controller, we can see, in my opinion, this is really easy to read. When I now remove this, we can see that this fits just on one screen, and you can easily understand what happens. If you're interested in how this works in detail, just go into the class and you see what happens there. So let's backtrack a little bit before we do some performance testing. What we achieved here. The first thing is we can really easily create our scoped values, our structured task scope, and pass to it some functions so that we can run them in their own virtual thread. Also, it's really easy to manage. We have really easy, effortless error management. We can decide ourselves, do we want to handle exceptions immediately? Do we want to handle them later? We can also really easily extend them. We don't have to use a built-in joiner. We can just use or create one for our specific case. And I think this is the most important stuff. It creates readable, simple, and also testable code. You don't have to, you have your own framework or library to put asynchronous code back into synchronous. Everything just is still working as before. And you also don't have to rewrite your whole application to be asynchronous to test if this works for you. But let's go back into IntelliJ here, because we can do a little bit more, because this is still not as fast as it could be, because talk and most infos here are not dependent on each other. We can run them both concurrently. So let's just remove this here again. And what we now do is we just add another try with resources block, add another scope, and I will just use the normal structured task scope function here normal open function. Of course, you could now check yourself, was retrieve talk successful, was get info successful, but we will keep it simple for this case. So now we will just use scope.fork and say create a new virtual thread and run retrieve talk in it, create a new virtual thread and run get info in it. And then when we are done, we just call scope.join, wait for both of them to finish, and then we can just use talk.get and mostinfos.get. Now what happens here is a new request comes in from a caller. Then this is virtual thread 1. Then a new scope will get created by using this virtual thread, and this will then create 2 new virtual threads. Let's call them virtual thread 2 and 3. Now in here, in this get info, 3 more virtual thread will get created, and then we are waiting for the result. And this is like the whole promise of this structured task scope, that you are creating new virtual threads, and then you wait for them at a specific point. You want to wait until all of the stuff you have is finished, and then you can continue your work. And this is likely forgotten, but as you can see, all functions are still blocking. We did not change any function in our fake REST client. This is all still blocking code. So you can easily just rewrite your application and keep it blocking. Just do some like proof of concept if everything still works. So let me now restart the application, and let me show you how fast this is. We restart this, we go back into JMeter, we clear everything. And now, of course, I change this from API talk to speaker, and we run this again. Now, as mentioned, because we're using virtual threads together with structured task scope, we will now see a huge speed improvement of that it again only takes 1 second, even when we are doing these 3 calls to our info endpoints, because we are doing everything concurrently. And in this case, it cannot be faster than 1 second, because we limited ourselves by using retrieve talk, which has a thread sleep of 1 second. So we can see here the response time graph is exactly 1 second, because, as mentioned, it can't be faster in our case. It will always be as slow as the slowest request. Now, let's go back here. Now, this is all nice, but there is still some stuff we have to take care of, because before we were using structured task scopes, even when we were using virtual threads, we still had a one thread per request model. So you have 1 thread, and you keep this 1 thread available for your whole request, and then it's free to do other stuff. Now when we are using structured task scopes, we have multiple threads running for 1 request. So stuff, for example, which uses ThreadLocal will not work as you expect. Let me show you what I mean with this. Let's go back into IntelliJ, and let's create a really simple filter function here, a filter class here. Now what this filter class will be, it will be a user filter, and we will implement the filter interface from Jakarta, and here we will just implement the do filter. So what this filter will do is, it will, as soon as a request enters our application, we will extract the user header from our request, and we'll store it in a ThreadLocal. So how do we do this? Well, the first thing we do is, of course, we say we have our public static final ThreadLocal, and this is of type string, and we say this is our user ThreadLocal. And now let's extract the header information. So we have our user here, and we have our HTTP servlet request, because we have to cast it, because technically it could be something else. In our case, it can't. And now we have extracted the user header. And for ThreadLocal, this is really easy. We can just use user ThreadLocal.set, and we set the user. Now we just call filter chain, do filter request response, and we are done. Now let's just say this is a configuration so that Spring will pick this up. And let's now go into our main controller and check if everything works as expected. We go in here, we say main controller, ThreadLocal, and we have our user ThreadLocal here. And we get the value from it. So, and we copy this, and we also go into the retrieve talk, and we do the same in here. And of course, we change this here to retrieve talk. And now let's restart the application, and let's see what happens here. Let's open our generate requests, and I have here a normal request to our endpoint with my user header, and let's run this. And what we now will see when we open the terminal, that as mentioned, in the main controller, we get the result, but in the retrieve talk, we don't get the result from our thread local. This is because retrieve talk is in its own virtual thread. When we go back into our main controller, we can see here that, of course, the request which enters our getSpeaker function, this is the first virtual thread which was created and also the one where the user thread local was set on. But here in scope fork, we create a new virtual thread, and because thread locals are not inherited like to other threads, this means that this is not available in here. So to fix this, we need something else. We need the new feature ScopedValues. Now, how can we use this? Well, let's create a new thread local here, and instead of thread local, we name this ScopedValue. Now in here, we say this is a ScopedValue, and we say ScopedValue new instance. Now let's see how this works. Let's try to use user_ScopedValue.set. We can see this does not work because a ScopedValue is not just working on the current thread. It works on, as the name implies, a scope, a context. So how can we change this? Well, we go in here and we say we have our ScopedValue and we say where, and you can see we have two arguments in here, a key and a value. So basically we're using this, we say where. The key is our user scope value we created up here, and the value is our user. And now when I end this statement, you can see here that it tells us, well, this doesn't do anything because this is not used. Because where returns a so-called carrier. This means that we can now use this value we have set and say for a specific scope, for a specific context, we want to set the user scope value to this user. Now, how can we do this? Well, we can use either run or call. Now, when we use run, we can see we get back void. When we use call, we get back the result. We get back the callable result. But we will use run here, and now we create a new lambda, and we can now pass our filter chain into this lambda. Because what now happens is we tell Java, okay, we have this value here. We have this scope value here, user scope value. We want to set its value to user, and we want to make it available in this context in here. So, and because the filter chain is like before our endpoint, before it hits our endpoint, we now have access in our endpoint to this user scope value. Now, let's go back into the main controller. Let's copy some code. Let's say we have here our main controller ScopedValue, and we are of course using here user ScopedValue. As you can see, .get can be called as with ThreadLocal. And retrieve talk, we are doing the same. We say we have our user scoped value and we say user scoped value.get. And now we're just restarting our Spring Boot application. And now when we go back into our generated requests and we run our request again, we will see that here for our main controller, of course, we also in the scope value get the value. And for our retrieve talk, we get also the value if we are using ScopedValues. Because as mentioned, it's not restricted to a thread, it's restricted to a scope, to a context which it runs in. And this is really powerful because let's see a little comparison between ThreadLocals and ScopedValues. The first thing is, of course, ThreadLocals are per thread. If you have one thread per request, this works perfectly fine. But ScopedValues are for a variable scope. You can, of course, you can also use ScopedValues if you are not using like virtual threads. You can use them. Let's say you have like a secret and you only want to run it in certain parts in your code. You only want to make it accessible in certain parts of your code. You just wrap this part of your code with this ScopedValue call, and in there you can then call this scope value and get the results. Elsewhere it's just null, it's not set. This is in sharp contrast to the ThreadLocal, where you set it once, but you can also set it multiple times and can access it everywhere. This is also the difference. ThreadLocals are mutable. So let's say you are setting the user ThreadLocal once in the filter. Everyone in your code can just call user ThreadLocal.set and update the value. You can't be sure that this value does not change, and you don't have clear access what happens now in your code. Also, scope values, of course, are read-only, so you cannot override a scope value. What you can do, of course, is you can go in there and you can say, okay, I now have set the scope value to this value for this scope, but maybe in my main controller, I want to change this. Maybe in here, I want to say ScopedValue.where, and I want to set the value here to something new. Of course, you can do this, but this would then be like an inner scope, which you can change, and you can still clearly see what's the context, right? But of course, you can do that. Now, the last thing is also that ThreadLocals don't know inheritance by default. You can use an inheritable ThreadLocal, but by default, they are not inherited. And scoped values are inherited by default into child scopes. That means that, of course, what I can do is I can just say, well, I have my scope value where I set this value here, but then I can just create another one which has another key, and I set another value in there. And the child scope still then has access to the parent. It does not lose access to the user scope value in this child scope in here. So it's really easy to do that. By the way, of course, you can set multiple scope values. You can just call where again, because the carrier just allows to set multiple scope values by chaining these calls. So one question is always, when should you migrate from ThreadLocals to scoped values? Well, you should really migrate if you're using not one thread per request. If you have multiple threads per request, then you should really migrate from the normal ThreadLocals to scoped values, because it's highly likely that you will not have access to your ThreadLocal variables where you expect to have access to it. It's also really cool that you can use this property, JDK trace virtual thread locals, and as soon as you try to call a thread local or set a thread local inside of virtual thread, you will get an exception so that you can test this like before you go to production. Also, I think you can even use scope values if you are not using, as mentioned, virtual threads. You can use them to set your scopes, set your values for a specific scope, which can really be useful. And also, if you want to have immutable data, if you want to be sure that not everyone in your code anywhere can just call threadlocal.set and update your values. Now, just a quick recap what we talked about today before we go to the questions. The first thing is, of course, we talked a little bit about how virtual threads work, that they are a construct which only lives in the JVM, which uses worker threads to do their job. And because we often have highly input-output optimized applications, this means that we can have basically like 40 worker threads for 1 million virtual threads. Then we saw also why we should use structured task scopes, because it's not enough to just have the virtual threads when it enters our system, but we can also leverage their power inside of one request to run stuff concurrently. And also how we can use scope values when we are using structured task scopes instead of thread locals, so that we can make sure that we still have access to these thread local variables or to these variables, because we now have multiple threads which in one request. So let's see if there are any questions, or if not, if there are any questions in the room. It doesn't seem to be. Does somebody have a question in the room right now? Yeah. 1 second, somebody will bring you a microphone so that everybody can hear you.
Thank you for okay. Do you have?
Yeah.
Thank you for a good explanation. I have a question about the facing with the problem of the deadlock or starvation. If we use the virtual threads, is there any improvement about these problems or no?
I'm not sure if I heard you correctly. About what kind of starvation?
About deadlock and starvation, that when we are using threads, we will have some problems like this, and we should manage them as a developer. Is there any improvement when we use virtual threads or no?
If you're having deadlocks, this will not help you, because it's like, it's the advantage plus the disadvantage. It's like the same as a normal thread. If you have like a deadlock, it will not really help. If you have like thread starvation, it can help you because you have more virtual threads available. If you're doing highly large input-output stuff, then it could help you. But it really depends on your specific issue you have. And maybe if you can also send me maybe a message on LinkedIn if you want me to look at some code or something, then we can of course look this up a little bit.
Thank you.
Cool. Yeah. Other question right over there. Yeah.
Maybe this is a little bit out of context, but I wanted to ask anyways, because
sure.
that's something that I've
Sure.
been working with. So let's say that I have a CPU-intensive application that is clearly being blocked by that intensity view. So something like expanding nodes on a graph or something like that. Would virtual threads help me on that sense? Because from what I have been searching, I guess that would fall into multiprocessing rather than virtual threads, but that would need CPU cores, real CPU cores, right?
Yeah, and this is exactly the case where virtual threads will not help you, as you maybe already have guessed, because if the virtual threads help you in the cases where your thread is not busy, but if your thread is busy doing stuff, it will not unattach itself from the worker. But what you can do, and this is a really nice question, so maybe I can give you a quick glimpse. What you also can do is, in your scope here, you can always say you want to create, you want to have a configuration. So we can have like join await all, and now we can have a configuration in here where we can configure the thread factory. So we can even say, for example, if you know you need to do stuff in parallel, but you don't want to use virtual threads, you can also configure your own thread factory and use like thread factory with normal threads, not with virtual threads. So this would be, you can absolutely use this. You always have to be, this was also a question like the last time I did this talk was, well, can I in Spring Boot change for specific endpoints maybe if they are using virtual threads or normal threads? Because what you always have to think of when you're using virtual threads, suddenly your system is much faster, but maybe you are relying on other systems which rely on the fact that your system is slow, right? For example, if you have a core system which can only handle like 10 requests per second and now you're sending them like thousands, then maybe this will like collapse. So always keep that in mind, like do some load testing on the other stuff if it can handle your stuff, or then you would have like to throttle it a little bit.
All right, that makes sense. Thank you.
Are there? Yes. Yeah, exactly. You could throttle the request, and of course you can also in there, like also for example, you can say you can also add a name to it, for example, for all these scopes, so that you can see it better in the stack trace when something happens, that you can differentiate between the different kind of threads which gets created. So this is all something which they added quite with Java 25, that you could do this, because I think many people were thinking, well, I need to be able to configure this a little bit better to use different kind of threads. Yeah. Are there other questions? It doesn't seem to be. So if you have any questions later, just go to Typerox or go to my LinkedIn, add me a request. And if you have any questions, just send me a message and I would love to have a chat with you. And otherwise, I wish you an awesome conference and thank you for being here.